Good afternoon, my dear students. How are you? Welcome to a new week ahead and welcome to one more fabulous session with Infinity Learn. I am Suresh, Faculty of Chemistry from Infinity Learn by Sri Chaitanya. How are you, my dear students? Hello, hi. Good number of students we can see there. Fine. Great, good afternoon. Hi, hi, hi. So, welcome to the series of lessons and lectures from YouTube platform. Here we are providing lectures right from 12 o'clock to evening 6 o'clock. These sessions include physics, chemistry and biology NEET STEPUP 2025 program. Okay, Kala, right, good afternoon. In this series I am chemistry faculty here providing chemistry lessons. In a week, first 3 days we are going to discuss with 11th standard syllabus, and next 3 days of a week we are discussing about 12th grade syllabus. So, in this Monday we are going to discuss 11th grade curriculum, that is alkene hydrocarbons. In the previous week this is connected to alkane. Hi Ishita, hello. You are present today. Very good. So, what we learn about alkane in the previous session, if any student right now here is not present right now, you please watch those recorded videos, okay, and you please like and share and subscribe these videos you are attending on the YouTube platform is absolutely free. So, these video lessons we are getting is complete, सारा के सारा NEET का syllabus आपको दे देंगे, okay, so that you will be well prepared for NEET 2025. जो भी हुआ, क्या हो रहा है NEET 2024 में, कुछ गड़बड़ है, so happened is happened, don't worry about that. We are not in a position to just introspect and prosecute all these things. Let happened, right? So, we have to prove ourselves for this drop for the next 2025 NEET examination, my dear students. Karthik, hello. You want to come for Sri Chaitanya main branch? I am at Sri Chaitanya main branch, NEET 720. Who is that? Good afternoon. Good afternoon. So, in this today's lesson, we are going to discuss about alkene. When you are okay with alkene, I can assure you this alkene is connected to alcohol and alkyl halide. So, in the hydrocarbon junction box, alkene is the very important part of the organic chemistry. If you are very good at alkene, you can do many things in the organic chemistry. 30% of the organic chemistry you are confident. Believe me, you can do the best. है ना? Moria, Karthik, city it is at Hyderabad, my dear students. Karthik, you want to come here? Good afternoon, Bappa. Good afternoon. Oh, very good. So, shall we start? Any doubts as far as alkane part is concerned? You tell me. Alkane CnH2n plus 2, and they undergo free radical addition reaction and छोटा मोटा आपका ऑक्सीडेशन रिएक्शन बस एंड कंबस्टन रिएक्शंस, उसमें कुछ प्रेशर नहीं है, लेकिन आल्कीन जो है उसमें ज़्यादा एम्फासिस देना पड़ता है बेटा. ओके, यू आर फ्रॉम महाराष्ट्र, ग्रेट, वेरी नाइस, राइट. ओके, any doubts as far as alkanes are concerned? We discussed Newman projections, conformations of alkanes, remember? Yes. Okay. Supriya. Hi everyone. Who is that Supriya here? You are a new student in this batch. Okay, छोटा मोटा discussion भी होना बीच में. So you said hi everyone, but not hi, no hi to sir Supriya. You are from Bihar, NEET 720. Who is that name? I can see total chart box in front of me. Okay, you are from Bihar means Bihar, am I right? Okay, आगे बढ़ेंगे. Alkenes the best alkene class you are going to get in today's class, children. How? Let's go ahead. Alkenes. General introduction of alkenes, preparation of alkenes is the main course for today's class. If possible, we'll start the properties of alkenes as well. Okay. My name Alpha. Okay. मैं पहली बार सुन रहे हैं अल्फा का नाम किसी बच्चे का नहीं अभी तक. ओके. सो Kurnool, Naidu. Okay, Kurnool, you are from Kurnool. Okay, so let us not discuss about our personal identities. Okay, just name is enough. So, my dear students, I request all you guys, you please take a notebook and a pen and go ahead along with my lecture and मेरे साथ लिखना है. अगर मैं कुछ क्वेश्चन देना तो आप जरूर करना है, करने का कोशिश करना है. लेट इट बी, एक गलत होने दो, मैं करेक्ट करने को मैं कोशिश करता हूं मेरे तरफ से. ओके, इफ लेट इट बी रॉन्ग आई विल मेक इट करेक्ट. ओके, सो लेट्स स्टार्ट विथ alkenes. Fine. So alkenes. Alkenes are a group of unsaturated hydrocarbons. They have carbon to carbon double bond and carbon undergo sp2 hybridization like this, and its structure is going to be like this. And this sp2 hybridized carbon, because of this sp2 hybridized carbon, you have a planar triangular geometry. So alkane part is going to be planar. So it has CnH2n molecular formula and it has only one double bond is there, degree of unsaturation is 1, and when it is named, suffix "ene" should be added. So ethene, propene and bute, one ene like that, ethene like this, propene like this, and bute one ene like this. Everybody knows about it, उसमें कुछ खास बात नहीं है. Okay, so it goes on like that. Let's talk about when carbon is connected to three other atoms, that is one of the bonds is a double bond, the molecules are modeled by the combining 2s and 2p orbitals. So it is an sp2 orbitals. Because of the sp2 orbitals, its structure is going to be planar. Let us talk about carbon 3 sp2 hybridized, and it has unhybrid orbital like this. If you take one more carbon like this, it is also undergoing sp2 hybridized. It will have unhybridized p orbital. Let it be here hydrogen or hydrogen. So between these two, Ishita, can you see the red color here? So that is called a pi bond. This pi bond gives its property. So जो भी properties है ये alkene का वजह से, ये pi bond का वजह से आ रहा है. So this pi bond is easily broken and it can be polarized by electromagnetic effect, whatsoever effect it may be, and it can give its bond in heterolytic way or homolytic way. It gives its electrophilic or free radical addition reactions. This is about the introduction of alkenes. So when you talk about preparation of alkenes, अभी तो कहानी शुरू होगा. So ये पहले मेथड जो है डिहाइड्रेशन ऑफ अल्कोहल्स. ये डिहाइड्रेशन है क्या इशिता? डिहाइड्रेशन है क्या? अरे इतना धूप में समर में डिहाइड्रेट हो रहा है का मतलब क्या? यू आर लूजिंग वाटर फ्रॉम योर बॉडी. ओके, पानी निकल रहा है, राइट? सो अल्कोहल से वाटर is removed so that alkene is formed. This is an alcohol. When alcohol is heated with acid, and you are going to get an alkene. So how? This is a beta elimination. So I just want to say a word called beta elimination. Beta elimination is a process of elimination. Children, Ishita, are you able to hear me? Children, please confirm, are you able to hear me? Are able to see my screen and me? Please give a confirmation. Children, please give me confirmation. Children expecting, please give me confirmation. Right. I'm expecting confirmation. Come on. Hello my dear students, can you all able to hear me? Hello my dear students. Yes. Are you able to clearly see me and hear me? Ishita, Supriya, Karthik. Just give a thumbs up there. Just give a thumbs up. So I am expecting you all can hear me. Right. Okay. So beta elimination means it is an elimination process. You can see carbon is tetravalent. Here it is a leaving group, a group that is leaving, and this carbon where the leaving group, L stands for leaving group, is called as alpha carbon, and इसका जो बाजू वाला है ए बीटा कार्बन होगा. अभी तो है right. So there is a hydrogen. So beta elimination means elimination of a leaving group and hydrogen from the beta carbon. So this is removed and this is removed. Okay, so that you are going to see the formation of, if this is removed, दोनों का बीच में एक डबल बॉन्ड होगा. So this is what you call it as a beta elimination. In this beta elimination, this is your leaving group, this is your leaving group, and this is your beta hydrogen, and this is alpha carbon, and this is your beta carbon. Can you able to see me? Alpha carbon and a beta carbon. So OH group from alpha carbon is eliminated and hydrogen from beta carbon is eliminated. So it is an acid catalyzed dehydration. So दोनों का बीच में एक डबल बॉन्ड आने वाला है. So it is called as an alkene. Formation of alkene from alcohol is catalyzed by an acid and it forms a carbocation. Let us see how this mechanism helps, so that you can see we are preparing alkenes. Not only we are looking at the properties of alcohols, my dear students. So double फायदा निकालने की कोशिश करो, right? So देखता हूँ कैसा आ रहा है. So that ease of dehydration. So this is an alcohol है ना, जो alcohol group है, if it is depends on the type of carbons. You know what is a primary carbon, secondary carbon, tertiary carbon, right? So the one ease of dehydration of alcohols, tertiary alcohols is greater than secondary alcohols is greater than primary alcohols. This is very important point as far as NEET examination is concerned, because NEET में ऐसा क्वेश्चन पूछने का संभावना है. Okay, because the alkene formed are more stable. So ease of dehydration, any elimination, you are going to see the formation of either alkene or alkyne. Let us talk, today's class is about alkene. So ease of that reaction or rate of that reaction is directly proportional to the stability of alkene, that is governed by Saytzeff rule. We can discuss it later. So here ये क्या क्या चीज इस्तेमाल कर सकते हैं. ये dehydration process में various dehydrating agents can be used for dehydration of alcohol. पहला जो है, so concentrated H2SO4 ये हाई टेम्परेचर में इस्तेमाल करना, सो नियर अबाउट 180 डिग्रीज 170 डिग्रीज से ऊपर, इससे कम नहीं होना चाहिए, राइट। और H3PO4, ओके, फास्फोरिक एसिड, अगर फास्फोरिक एसिड इस्तेमाल करना चाहते हो तो और ज़्यादा टेम्परेचर चाहिए आपको 470 केल्विन, और यू कैन से Al2O3, it is in the vapor phase, okay. You can also use phosphorus pentoxide. Phosphorus pentoxide is a famous dehydrating agent used in chemistry, my dear students. And heating with POCl3, phosphorus oxychloride, okay, or phosphoryl chloride with pyridine as a base, okay. नीट में ये इतना important नहीं है, ओके। हीटिंग विथ KHSO4 ये काफ़ी इंपॉर्टेंट है, ये काफ़ी इंपॉर्टेंट है, काफ़ी इंपॉर्टेंट है, ओके। these are all very important. So when you look at the chemical equation in the NEET examination, on equation में कुछ लिखा हुआ, ये reagent देखने के बाद आपको पता चलेगा कौन सा रिएक्शन कर रहा है. Are you getting or not, my dear students? चलो thumbs up दे. इशिता, are you there? Hello? Okay, come on, let's see. Stability of alkene during, एक minute, yes. So more substituted alkene is more stable due to hyperconjugation we discussed. So during dehydration it is formed. Ease of dehydration is directly proportional to stability of alkene. Okay, so that I would say ease of is directly proportional to stability of alkene. So alkene stability decide करने के लिए हाँ कर्तव्य checked by plus I effect also agree. It's an outstanding interpretation कर्तव्य. But here stability of alkene बोलने के लिए आप पहले hyperconjugation देखना पड़ता है. Okay, hyperconjugation effect is more effective than inductive effect. That's the reason why inductive effect is also true, but inductive effect is a weak effect. We have to look into the hyperconjugation effect. समझ में आ रहा है क्या? So that here more substituted alkene is more stable. Here substitution देखना पड़ता है आप लोग. यहाँ पर देखो ये substituted है, ये substituted है, ये भी substituted है. लेकिन यहाँ पर 4 सब्स्टिट्यूशंस था, अभी तो 3 सब्स्टिट्यूशन बच गया. अभी तो सिर्फ 2 सब्स्टिट्यूशन है. सो एज मोर सब्स्टिट्यूटेड मोर स्टेबल, लेस सब्स्टिट्यूटेड लेस स्टेबल. अंडरस्टैंड? स्टेबिलिटी ऑफ थर्ड एंड फोर्थ इज शेक इज रेजोनेटिंग स्ट्रक्चर 1 2 3 4. ना. If it is an excellent, it is an excellent interpretation. If it is like just I want to discuss this structure and this structure, right? Kartavya. Definitely this particular YouTube session is not a radio session. This session is a live interactive session. That's the reason why attend the class regularly. The questions you are asking, Kartavya, definitely I appreciate, and I am going to solve your doubt immediate effect, right? So this is written as CH3 and CH3 CH2. This structure I would like to write CH3 C double bond C CH3 and H. This is isobutylene and this is transbutene. Isobutylene is more stable than transbutene because if you write hyperconjugation structure for this, you are going to get a primary carbanion. If you write hyperconjugation structures, you are going to get a secondary carbanion. Primary carbanion is more stable than secondary carbanion. That's the reason why isobutylene is always more stable than transbutene. Of course, cis is going to be less. Fine. Kartavya Rana. One more Rana I could see in the same class in the previous sessions. Okay, come on. Let's go into this mechanism of acid catalyzed dehydration. First of all, let me give you, yes, first step in this mechanism. If you could able to see this is a alpha carbon where OH group is there, and this is a beta carbon. This is a beta carbon, this is alpha carbon. So when strong acid like H2SO4 is taken, Hu plus is taken by the lone pair of electron present on the oxygen. Sir, NEET examination में आपका mechanism चाहिए? Of course it is not, but sometimes based on mechanism we have to predict the proper appropriate answer. That's the reason why for formality's sake I am giving you, right? So that OH is a poor leaving group. It's a leaving group, but it's a poor leaving group. I want to kick out OH so easy, so that I just want to add one proton. Now it is going to be OH2 plus. It is going to be OH2 plus, right? So OH2 group is a good leaving group. When this good leaving group is there, it leaves off, is a conjugate acid base reaction, so that that counterpart of anion is going to take the beta hydrogen, so that this is lost. Okay, so you are going to get a carbon with a double bond and alkene is formed. Okay, carbon with double bond and alkene is formed. More substituted alkene is formed. Here you can see, I just want to write my own structures like this, like you see, you can also write this mechanism like this. If it is looking clumsy, this is alpha carbon, this is beta carbon. When Hu plus is added from the acid, the lone pair of electron present on the alcohol is going to attack this acid, so that it's a Bronsted base. Okay, so you are going to get OH2 plus. OH2 plus is going to be a good nucleophile. Students kept quiet, I don't know. Okay, so it is going to be lost as a water molecule. So you will be seeing the formation of a carbocation. So that formation of a carbocation is the rate determining step. Carbocation is formed. This carbocation is stabilized by the loss of proton, dear students, so that it is lost as a proton. So you got your fast a double bond, alkene is formed. Here जो कार्बोकैटायन फॉर्म हो चुका, it can rearrange. ये तकलीफ है इसका. Are you getting or not? So Naidu, fine. Kartavya, Maurya, give thumbs up in the class. Give thumbs up in the class. Come on. Fine. और एक example करेंगे इसका. Carbocation can rearrange. Come on. Right. Look into this. Yes, the first step is dehydration. So first step is, you can see, the first step in the dehydration of primary alcohol is a protonation. What is the meaning of this? Addition of H plus to the alkyl group is called protonation, right? And the second step is attack of conjugate base at a protonated alcoholic group. So second step is attack of this conjugate base to the protonated alcohol. Okay, so and the elimination of protonated hydroxyl group as a water molecule. Okay, so rate of the reaction is directly proportional to the stability of concentration of conjugate base and a protonated alcohol, you can say ROH2 plus. So it is a bimolecular reaction, chemical kinetics. It is a chemical kinetics related question, remember? So it is a bimolecular elimination reaction. Okay, kinetics of the reaction of the second order and bimolecular to eliminating groups like hydrogen OH group must be in antiposition, that's a different matter. Okay, so arrange the following alcohols in decreasing. How the questions from NEET examination can be asked in decreasing order of the ease of dehydration with H2SO4. So like these questions, if you are able to do, definitely your journey to pursue your coaching in NEET 2025 is going to be awesome, right? Otherwise, you keep on reading, you keep on writing, you keep on going for the exam, again you will bounce back. So we prepared these slides in such a way that you can do the best in NEET 2025 exam. So please believe us and follow the things what is happening in the class. Dear students, please like these sessions. Or somebody, yes, if you are able to hear me, just give thumbs up in the class. Who is the NEET 2720, or next time you make it NEET 2025, huh? Okay, right, come on. So arrange these following alcohols in decreasing order of their ease of dehydration with H2SO4. So if you see the mechanism first, mechanism का हिसाब से बोल सकते हैं ना. So in this I could found carbocation, right? So stability of the carbocation, chemistry में एक चीज़ है, ये हर रिएक्शन का एक ही फंडा है. So more stable is the reaction intermediate, more is the major product. So a major product is formed from the more stable intermediate, and the rate of reaction is always proceed towards the more stable intermediate. So जिस अल्कोहल more stable intermediate दे सकते हैं, ये more reactive होगा. So that you can see the reaction here. Yes, if this is removed, this is your carbocation. If this is removed, this is your carbocation. So I just want to say, if this is removed, if this is removed, if this is removed, if this is removed, if this is removed. So let us see the respective carbocation. आपका जो carbocation मिल रहा है ना, so this carbocation सबसे ये वाला है ना, so carbocation C is a tertiary carbocation, is more stable है ना, then it is also a tertiary carbocation, लेकिन hyper conjugation उसमें ज़्यादा है. Okay, hyper conjugation उसमें ज़्यादा है. and D वाला ये भी ये secondary carbocation है, ये secondary carbocation, ये भी secondary carbocation, ये primary carbocation. Stability of carbocation, tertiary carbocation more stable than secondary carbocation than primary carbocation. Therefore C is more than B, क्योंकि C में hyper conjugation ज़्यादा है, more hyper conjugation, and relatively less hyperconjugation. And D, it is a secondary carbocation, and A is a secondary carbocation. ये secondary carbocation में hyperconjugation ज़्यादा है, लेकिन E is a सिर्फ primary carbocation. So This is the correct order of ease of dehydration of alcohol. So, this kind of orders you need to know for NEET exam 2025 preparation. Everybody can do dehydration, everybody can write the product, but you have to check the correct order. This is the correct order, my dear children. Fine. So, please interact with me. जो भी students है class में, okay, near about 350 students are there. You kept quiet in this chat box. I want to know, do you face any technical difficulties during the class? Students, come on. Just let me check. Let me check. Come on. Give thumbs up if you are able to hear me. I think some kind of chart glitch is there in today's class. Let us continue our class. Okay. Now, rearrangement and ring expansion. Yes, rearrangement result in the substitution, elimination and ring expansion and sometimes ring contractions. So, in case of cyclic alcohols, whenever a carbocation is formed outside the next carbon atom to the ring expansion takes place to relieve the ring strain. So, I just want to say a carbon is ring if the ring is attached to carbon like this. So, in this case ring expansion takes place. Carbon positive charge immediately attached to the ring, then ring expansion takes place, may ring contraction takes place. But ring contraction case कम probability है, but ring expansion के ज़्यादा हो सकता है. So, I just want to give you, this is an example, okay. This example I want to make it by my own handwriting. Look at this. Okay, this is the one, right? This is the one, am I right? Okay. So, when this is treated with an acid, there is a lone pair of electron. This lone pair of electron is going to take H plus. Ishita, are you there? Okay, come on. Yes. Who is that ReX2OP? It is going to give you a protonated alcohol. Now, protonated OH2 group is a better leaving group, so that it loses this as a water molecule. As a result of this, you got a carbocation like this, right? So, everybody, you can see this carbocation, this ring has 5 carbon atoms. So, 5 carbon atoms ring and 6 carbon atoms ring. 6 carbon atoms ring is more effective stable because it has a less ring strain. So, 4 carbon atom is less stable than 5 carbon atom, 5 carbon atom ring stable, less stable than 6 carbon atom. So, that what happened, this pair of electron, this pair of electron is going to attack there, right? As a result of this, ring expansion takes place. So, that look at this, there is a bond here, right? So, that bond goes there, that bond goes there. As that bond goes there, there is a new bond between here. Yes, there is a bond between here and here, the bond becomes a positive charged. Got it? Got it? So, that this structure, I just want to say carbon 1, 2, 3, 4, 5, 6. A positive charge. Now its side carbon atom should lose one of the proton here to give rise a carbocation like this. So cyclohexene is the product. Fine. So like this there is a ring arrangement. So that rearrangement is known as Wagner rearrangement. That rearrangement is known as Wagner rearrangement. Hope you are all understanding that is given in this slide like this. Okay, the same thing is given, ring expansion, bond breaks at C1 and C5. So if this bond is broken, a new bond is formed between C5 and C6. So that you left with a carbocation at C1. It's a secondary carbocation. The secondary carbocation can give you cyclohexene in the same manner, right? So you can take this or you can take this. So it is better cleared by my own handwriting. Okay, children, fine. Any doubt here? Any doubt here? Okay, आगे बढ़ो. अरे कम से कम thumbs up देने हैं chat box में. Who is that? Vanga Annamani want thumbs up in the class, right? Excuse me, sorry. Excuse me. Karthik, fine. Let's see. Now, preparation of alkene by partial reduction of alkynes. That's perfect. That's perfect. I can see like R C triple bond C, it can be reduced by PD H2, PD BaSO4 in H2, okay, or CaCO3 can use. You can use sodium or lithium in liquid ammonia. There are three methods I just want to say. Okay, so PdH2 or C triple bond Cr dash. It is an alkyne. This alkyne when directly PdH2 करेंगे तो क्या होगा? You are going to get R CH2 CH2 R dash. It is an alkane is formed because hydrogenation is uncontrollable. So alkyne directly gives rise to alkane in the presence of palladium or platinum और निकेल, जो भी कैटलिस्ट आप इस्तेमाल करना चाहता हो तो alkyne alkane देते हैं. लेकिन ये कैटलिस्ट जो इस्तेमाल कर रहे हैं ना उसमें थोड़ा बेरियम सल्फेट और कैल्शियम कार्बोनेट पॉइजन करना, so that the catalytic activity is decreased partially. Therefore what happens? So this is going to be converted into C double bond Cr dash and hydrogen. So alkene is formed. If you use sodium or lithium in liquid ammonia, so you are going to see the formation of R C double bond Cr dash and you will get H and H. Here is also alkene is formed. ये दोनों alkene का क्या फर्क पड़ता है? कर्तव्य राणा वाणा ask you ये दोनों alkene का क्या फर्क पड़ता है? जब ये PdBaSO4 इस्तेमाल कर रहे हैं ना आपका मिलेगा cis alkene, so that it is forming a trans alkene, right? So cis alkene and trans alkene. So this is known as Lindlar's catalyst. This is known as Lindlar's catalyst. Lindlar's catalyst, and this reaction is known as Birch reduction. That is what it is mentioned here, dear children. Dear children, you can see preparation of alkane by partial reduction of alkynes. You, my dear students, you please join in Telegram channel of Infinity Learn, so that सारा के सारा notes आपको PDF मिलेगा. Okay, you are going to get the live session updates, examination updates, test series updates, any program launch updates and the class updates. Everything you are going to get in these channels. That's the reason why you please join in Infinity Learn YouTube channel and you please like, because हमारा तरफ से इतना मेहनत कर रहे हैं हम लोग, so आप भी मेहनत कर रहे हैं, so जो हम कर रहे हैं ना, आप लोग को, आपका फ्रेंड्स को भी फ़ायदा होना चाहिए. Therefore, we request you to share this session with your friends and subscribe to the channels that is provided here, right? So it is there in the description box, you can do it. Okay, chalo beta. So the catalytic hydrogenation of alkynes to alkenes occurs in the faster than of alkenes to alkanes. Therefore, by using a specific catalyst, it is possible to stop the reduction to give the cis trans alkenes, cis or trans alkenes, depending upon the nature of the catalyst. If it is cis alkenes are formed by hydrogenation in the presence of PDBaSO4 or CaCO3. ये BaSO4 CaCO3 का फायदा क्या? हाँ, yes, they are catalytic poisons. Surface chemistry. We are connecting with organic chemistry with chemical kinetics, organic chemistry with surface chemistry, organic chemistry with, you can connect with thermodynamics sometimes, my dear students. We are connected with conjugate base बोल रहे हैं उस समय में वो equilibrium का है ना? Got it? So that is called Lindlar's catalyst. You can use quinolone or quinoline as a solvent. This is solvent beta. This is actual catalyst. So this is catalytic poison. This is actual catalytic poison. You can use B2H6 in THF or any ether in the presence of acetic acid, right? So it is a wonderful lecture that I am giving to you guys, that is useful for your NEET examinations. Okay, transalkenes are formed by hydrogenation in the presence of sodium in liquid ammonia or lithium in liquid ammonia. You can say it is a Birch reduction. Okay, fine. Okay. Now, so from alkyl halides or haloalkanes. So by dehydrohalogenation, so we discussed it so far. We prepared alkene from dehydration of alcohols. We prepared alkenes by partial reduction of alkynes, and we are about to prepare alkenes by dehydrohalogenation. What is the meaning of dehydrohalogenation? D means remove. Hydrogen and halogen. Okay, so dehydrohalogenation. So again this is going to be alpha carbon, a leaving group है, and beta carbon. Okay, and the hydrogen to this is a beta hydrogen. Alkyl halide, the halogen and the beta hydrogen are removed so that an alkene is formed. So this reaction is called as dehydrohalogenation. This is a very, very, very important. If you are able to do, you can do haloalkanes. You need alcoholic KOH, any base आप इस्तेमाल कर सकते. Okay, sodium hydroxide in alcohol. Okay, पोटेशियम हाइड्रोक्साइड इन अल्कोहल या मिथाइल अल्कोहल इस्तेमाल कर सकते हैं और एनी बेस NaNH2 भी इस्तेमाल कर सकते हैं. लेट्स गो इनटू द डिटेल्स. इज वेरी वेरी इंपॉर्टेंट. इफ यू आर एबल टू डू दिस, सो alkene प्रिपरेशन इज ऑलमोस्ट डन, है ना, ऑलमोस्ट डन. ओके, आगे बढ़ेंगे. सो क्या कर रहे हैं? सो दिस इज आयोडो ईथेन इथाइल आयोडाइड. सो ये अल्फा कार्बन है, ये लीविंग ग्रुप है. सो बीटा कार्बन HI निकाल अल्कोहल KOH, ethene और ethylene is formed, right? Now one bromopropane, this is a leaving group and beta hydrogen, HBr is removed, right? So what is happening here? What is happening here? You can see, yes, carbon, KOH is a base. KOH is a base. So that you are going to take, what is a base? Somebody tell me what is a base? What is a base? Base is a substance which react with, which attack on H plus. So that base is going to attack this H plus, so that this bond is going to be shifted here. So as a result of this, a transition state is seen. Let me tell you how this transition state appears to you. Yes, this makes a bond here. This bond becomes weak, so that there is a new bond that is about to establish between these two. There is a new bond that is about to establish. Yes, Amarinder Singh. Now I can see somebody is shouting with me. Okay, you are all able to hear me. Give a thumbs up better, because there is a glitch in the chart. Ishita, hello, give a thumbs up in the class so that I can see my dear students. Okay, right. So as this bond is coming down, there is a bond, new bond is about to establish. Yes, that's good. Now as this bond is about to break, so there is a bond about to leave. So this is what you call it as transition state. So this transition state is a part of elimination by molecular. So as this bond between these two is formed, you are going to see the formation of H2O, and this Br minus with K plus gives rise KBr. That's the reason why we just write KBr. KBr plus, you can see this is the one, a bond, this is the one, a new bond is introduced here, it is an alkene. Amarinder Singh, hope you all understood this mechanism. It is an elimination by molecular reaction. Elimination by molecular reaction. So this is rate of a reaction is equal to K and alkyl halide and base. The base is here, OH minus is a base. जो भी base है, okay, जो भी base है, okay. So here I just want to say, if a probability of the product is there, what we have to do, that's given in the next slide. So you are all following Fine, that's good. Now in this process, removal of molecule of a halogen like HCl, HBr, HIs takes place. So to form an alkene, this process is known as dehydrohalogenation. D means remove, hydrogen and halogen. So removal of hydrogen halogen is called dehydrohalogenation, my dear students. So dehydrohalogenation example of elimination. Since this reaction, hydrogen is removed from beta carbon, hydrogen is removed from beta carbon and halogen is removed from alpha carbon. This is your beta carbon, this is your alpha carbon. है ना? So in the ease of dehydrohalogenation of alkyl halide, the same alkyl group but different halogens. Alkyl iodides are more reactive than alkyl bromide is more reactive than alkyl chloride. You don't put alkyl fluoride in general chemical reactivity. Fluorides का बिल्कुल अलग तरीका react करता है. Okay, you say fluorine is more reactive, sir. Fluorine is more reactive, but alkyl fluoride is less reactive. समझ में आ रहा है क्या? Fine. Okay. So different structures. So tertiary alkyl halides, secondary alkyl halides, primary alkyl halides. So tertiary alkyl is more reactive. Here Saytzeff rule. I just want to give you Saytzeff rule. What is the Saytzeff rule? I'll tell you. Saytzeff rule. Look at this. CH3, CH2, CH, CH3 and bromine. That is 2-bromopropane, 2-bromobutane, 2-bromobutane, right? This 2-bromobutane, if it is heated with potassium hydroxide, I know it is alpha carbon atom. Yes, bromine चले गया, लेकिन हमारा पास ये बीटा होगा, ये भी बीटा होगा. जो भी साइड कार्बन है बीटा होता है ना. अमरेंद्र गिव मी थम्स अप, राइट? ओके, अगर आपका जो है this is a beta carbon. So if I remove bromine and blue color beta, I am going to get a product like this: CH3, CH2 and CH and CH3. So that a double bond is placed here. If I remove a red color beta wala, so that I can get CH3, CH and CH and CH3. अगर ये रेड कलर बीटा निकाल देंगे तो आपका मिलेगा ये प्रोडक्ट, राइट? सो ये दोनों प्रोडक्ट में मैं आपको कह रहा हूं ये वाला मेजर होगा, ये वाला माइनर होगा. Why this is major, why this is minor? That is given by a rule called Saytzeff rule. This is your Saytzeff rule. Depending upon the structure, alkyl halide may give one or more isomeric alkenes. So dehydrohalogenation of 1-chlorobutane. Okay, so this is where I just want to give you here itself. So why it is major? This is given by Saytzeff rule. Anybody can give you a Saytzeff rule? Come on, jaldi dena. NEET 720, Ishita, Supriya, okay, Vanga Annamani, Karthik, Babulkar, okay, REX2OP, okay, Kartavyarana. So Amarinder, anybody can give you what is the Saytzeff rule? ये example के हिसाब से, ये example के हिसाब से somebody give me so that I'll understand. Somebody give me so that I can understand. Right. Saytzeff rule says here, whenever more than one beta hydrogen is available, the beta hydrogen is available from the carbon which bears the least number of hydrogens. That is what you call it as Saytzeff rule. Here I just want to say the product that is formed is a more substituted alkene. During elimination, the product formed is more substituted alkene. That is one statement I can give you. Here two substituents are there, here only one substituent is there. Okay. Right, you can also say if more than one beta hydrogen is available, if more than one beta carbon is available, I just want to say the beta hydrogen is eliminated from the carbon which bears the less number of beta hydrogen with it. The carbon with less number of hydrogen should lose hydrogens to form its respective alkene. So I just want to say poor becomes poorer, poor becomes poorer. ये याद रखना, अगर ये याद रखना तो आपको अच्छा ट्रिक मिलेगा. सो जिस कार्बन में 2 हाइड्रोजन से 3 हाइड्रोजन से, ये पूर्ण नंबर हाइड्रोजन से ना, सो यहां से हाइड्रोजन निकलेंगे तो आपको मेजर प्रोडक्ट ये मिलेगा. सिंपल टेक्निक फॉर दैट. अंडरस्टैंड? क्लियर? दिस इज अबाउट Saytzeff रूल. जब एलिमिनेशन में Saytzeff रूल इस्तेमाल करना. सो माय डियर स्टूडेंट्स, मेरे एक्सपीरियंस से बोल रहा हूं, मेनी स्टूडेंट्स फेस डिफिकल्टी इन अप्लाइंग Saytzeff रूल एंड मार्कोनिकॉफ रूल. मार्कोनिकॉफ रूल एडिशन में इस्तेमाल करो, Saytzeff रूल एलिमिनेशन में इस्तेमाल करो. समझ में रह गया? सर कहीं सम बुक्स Saytzeff रूल इट इज आल्सो सेड टू बी Saytzeff रूल. कोई प्रॉब्लम नहीं, इंसान एक ही है, प्रोनाउंसिएशन का हिसाब से ए रशियन साइंटिस्ट का. सो 2 डिफरेंट नेम्स आर translated from Russian language. It's not at all an issue. Right. Okay, let's talk about what is stereochemical aspect. Okay, so Saytzeff rule. And when bulky base is used, so what are the actual bases that you are using here? You are using base na, you are using this base. You can use potassium hydroxide in alcohol, जो भी अल्कोहल है, दिस इज वन बेस. और CH3ONA, CH3OH, उसमें CH3O माइनस Na प्लस, ये बेस है, ये बेस है. समझ में आ रहा है क्या? very important thing. You can also say C2H5O Na, sodium ethoxide and ethyl alcohol. This is your base, right? Now you just see tertiary butyl alcohol, potassium tertiary butyl oxide. So in this carefully you see size of the base छोटा है, OH माइनस छोटा है, CH3O माइनस और बड़ा है, C2H5OH. अगर अल्काइल ग्रुप का साइज बढ़ रहा है सो आपका अल्काइल ग्रुप बेस साइज भी बढ़ रहा है. ये वाला ये बल्की बेस है और बल्की बेस. So base become bulky. So this can be used, this can be used, this can be used, this can be used as a base in the elimination reaction, children. So what I mean to say, ये जो Saytzeff है ऑर्डिनरी बेस के लिए इस्तेमाल कर सकते हैं. ओके, इट्स एन ऑर्डिनरी बेस, राइट. लेकिन व्हेन ए बल्की बेस, जो बेस इतना बल्की होगा, सो एग्जांपल पोटेशियम टेरिसरी ब्यूटॉक्साइड. सो दिस इज योर पोटेशियम टेरिसरी ब्यूटॉक्साइड. सो Bu, ओके, वो माइनस के. सो पोटेशियम टेरिसरी ब्यूटॉक्साइड और टेरिसरी ब्यूटाइल अल्कोहल or triethylamine for the dehydrohalogenation. So what happened? Less substituted alkene is formed. So if you see this particular example, I just want to give you as how you just leave this statement. Okay, I just want to use this. I just want to use this space, or else. एक minute. I'll add a slide over here. Right. So when a bulky base is used, I just want to use, dear children, dear children, you can see CH3, CH2, CH and CH3. Here it is a Br. As we all know here, if you use a potassium hydroxide and you heat it, it is a small base. जब आपका ऑर्डिनरी बेस इस्तेमाल करना चाहता हो तो आपका Saytzeff रूल सीधा काम चलेगा. So that you are going to see this is a beta hydrogen and this is a beta hydrogen. So that you are going to see the formation of CH3, CH, CH and CH3. यहाँ पर आएगा ये डबल बॉन्ड, क्योंकि this follows Saytzeff rule we discussed. Whenever you want to, Sampath, Ramchandra, hi. So other students, please, if you want to use a bulky base like tertiary butoxide, potassium tertiary butoxide, tertiary butyl alcohol. So what the product you are going to get? You are going to get CH3, CH2, CH and CH2, इसमें आपका आएगा ये प्रोडक्ट. Okay, so this indicates Hoffmann product. Hoffmann product Saytzeff product बिल्कुल उल्टा होगा, right? So what is the condition to get Hoffmann product? That is the key point in NEET examination. In the NEET examination एक खतरनाक point है, बहुत confusion point है. कब समय में, सब महीने में. Aditi Sampath is my grandfather name. Okay, so Aditi, God bless you, nice name. Okay, please attend these lectures every day 1:30 to 3 p.m. right? Today we are discussing alkenes preparation. Tomorrow we will discuss alkene properties. ठीक है? And is also details are given infinity length NEET 20 step up 2025 का है ना. So you please follow the instructions. ये link भी दिया जाएगा. So ऊपर जरा देखो, a link is given. You please follow that link. You will get updates, right? Aditi, okay, come on. So Hoffmann product you are going to get in two cases. Case number 1, जब आपका वो जो बेस इस्तेमाल कर रहे हैं ना, ये बल्कि होना चाहिए, बल्कि बेस, you will get Hoffmann product. Okay, and you have a poor leaving group. LG stands for, LG Samsung नहीं है, LG stands for leaving a group. No problem, Aditi, no problem. Okay, right? जो भी क्लास है आपके एक क्लास में फायदा उठाने की कोशिश करो. So it's a poor leaving group, right? So any kind of thermal decomposition reactions and thermal elimination reactions you have. That thermal eliminations NEET में नहीं है. Okay, so this is about Hoffmann product and Saytzeff product. So Hoffmann product is formed. This is what is given as an example. एक बार pursue कर लो बेटा. So please like this session, okay, and share with your friends. उन लोगों को भी फायदा होना चाहिए. Okay, and subscribe to the channel. So that is important, so that you will get an updates continuously. So this is about elimination reaction. And what about stereochemical requirement for bimolecular elimination? For the stereochemical descriptions, you can see a best example I can see anti-elimination. Anti-elimination. So anti-elimination means you can see the mechanism I have given. The leaving group, this is the leaving group, and this is the hydrogen. Both are eliminated. Na? One is in this direction, another one is in this direction. Understand? So if this and this is an anti, then only this elimination takes place. If you see the stereochemical descriptions, I can see, right, Br and a hydrogen, and a hydrogen. Of course, in this case, this is an alpha and this is a beta. So on the beta carbon, how many hydrogens are there, my dear children? 2 hydrogens are there. So कौन सा हाइड्रोजन निकालना वाला है? So when it is heated with potassium hydroxide, so of course this is eliminated, no doubt. This is eliminated, no doubt. And ये ब्रोमीन का एंटी हाइड्रोजन ये एलिमिनेट करना है, right? So I just want to say hydrogen 1, hydrogen 2, hydrogen 3, right? So that you can see the product here, a double bond here, hydrogen 1 and hydrogen 3 बचेगा. So this is what you call it as elimination by molecular dehydrohalogenation is anti-elimination. This is a very important parameter. That is the thing it is given here. Yes, if this is the structure, of course this is the leaving group, है ना. Now this is alpha carbon and बगल वाला जो ये बीटा कार्बन. So this beta carbon का anti position ये वाला है. So this and this are removed so that the product that is obtained in this way and as well as in this way. How do you get that? You will get because here two hydrogens are there, right. So अगर ये वाला निकालें तो ये minor product मिलेगा क्योंकि ये less stable है, less substituted. This is more substituted. More substituted alkene is more stable. Why? According to Saytzeff rule. So organic chemistry इतना complicated नहीं है, लेकिन the way you look at the structure, जो ये reactant है, product reactant ऐसे है, product आपको ऐसे दिखा दिया. Are you getting or not? So when you look at this structure, na, you are gone into the confusion. You don't go into that confusion. ये structure कैसे देखना है वो सीख लो पहले, then you will understand. Or otherwise, if I write this structure in the same way that you think, it is like this. Now there is no issue. There is no issue at all. And this is the structure. ये structure का हिसाब से मैं ऐसा लिखना चाहता हूं. हाँ, ये दोनों बराबर है ना, ये दोनों बराबर है ना. Understand? Clear? Fine. చాట్ రావట్లేదండి, చాట్ రావట్లేదు. Okay. So if this is the case, in the previous case, hydrogen methyl and hydrogen methyl, you can see the same way. If you can see in this way, if you use anti-elimination can occur in one way with the trans isomer also. So trans 1-bromomethyl cyclohexane is taken and this and with respect to this one and this one you can see. Anything can be removed so that this is the product is formed. If you want to take this and this, there is no reaction. That is the reason why. So it is an anti. Thank you, Ramachandra. Thank you, Sampath Ramchandra. Thank you. Great. You said it. Your name is Aditi, right? Okay. Talking about predict the order of reactivity, we discussed, right? So another method of preparation of alkene is Kolbe's electrolysis. In the Kolbe's electrolysis, we discussed the same way. In my own way, I will just give you, this is the chemical reaction that you see in your chemistry books. But in my view, you just see here CH2 potassium succinate. This is potassium succinate. Aqueous solution of this is electrolyzed. 2 water molecule Do you mind if I write the water molecule like this? You don't mind, am I right? You don't mind, fine. So, hey Ravinder, where did you go? आज लेट आया क्यों? हाँ दुबे, you tell me your doubt. अभी तो चार्ट में क्यों you kept quiet? स्टेशनरी क्लास के बाद जा सकते हैं ना, आज कमाल है. Okay, class is very important and today we did alkene preparation, elimination कर रहे हैं, dehydrohalogenation, dehydration, stability of alkene ज़्यादा कर रहे हैं आज. हाँ 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 कुनी नाक. Okay, okay, what is C there? Dubey, what is your doubt? Water can be written as H plus and OH minus. Thank you very much, Ravinder Reddy. Right. So, during electrolysis, क्या हो रहा है? This is eliminated as H plus this is eliminated as potassium salt of succinic acid K plus and OH minus, K plus and OH minus, it is removed as 2 KOH, right, and H plus and H plus is eliminated as H2 gas, and here carefully you see this is eliminated as CO2, and these are eliminated as CH2 double bond CH2. So, ethylene or ethene is formed. So, these two are formed at anode and this is formed at cathode. Right, these two are formed at anode, these two are formed at cathode. So, in the NEET examination आपको पूछा जाएगा, when potassium salt of succinic acid is electrolyzed in the aqueous solution, the products formed at cathode, the products formed at anode, you think there's something is happening in the electrochemistry as you are not aware of the electrochemical process. That is not, it is an alkene or alkane or alkyne may be the product. During Kolbe's electrolysis, you will get hydrocarbons. Fine beta? Hope you are understanding. Okay, Kunina Haka, what is C there, and Dubai, what is your doubt? I couldn't see what you typed there. So, some glitch in chart today, that's what I am just wondering. If you could able to post your doubt in the comment section also after recording, okay, after session is completed, I will read those comments and post my answer in that, right? Take care of it, not an issue. So, you can ask doubt in offline also. There are two ways: in the YouTube channel, in the recording, in the comment side, you can ask doubt, I can reply that doubt. Otherwise, you can go to the Infinity Meta app, there you can put your doubt. There are two methods, right? Next. So, physical properties of alkenes. Only weak van der Waals interactions are there in alkenes, just like alkanes. But alkenes is little polar due to the weak pi bond present in it. But whereas in the alkanes, they are absolutely non-polar, they are pure saturated. Okay. So, only weak van der Waals interactions. What are van der Waals interactions? They are kind of intermolecular forces. Where do you get intermolecular force? So intermolecular force you can find in the first page of states of matter, grade 11. We will be discussing in the future classes, right? So as they have weak van der Waals forces, they have low melting point. Melting point and boiling point of a compound is directly proportional to the intermolecular force. You have London dispersion force, ion dipole force, dipole force, and induced dipole force, hydrogen bonding. So you have a list of intermolecular force. You can read it and you can find it. Otherwise, you wait till we just start that particular topic talking about. So intermolecular force ख्याल में रखो हमेशा is directly proportional to molecular weight. Intermolecular force is directly proportional to surface area of the molecule. So increase in surface area, the number of carbon atoms increases, so that intermolecular force increases. So alkenes are soluble in organic solvents, सबको पता है basic, and of course they are insoluble in water. जो भी organic compound maximum insoluble in water except polar organic compounds. So cis-butene has higher boiling point than trans-butene, क्योंकि ट्रांसब्यूटेन में डाइपोल मूवमेंट कैंसिल हो रहा है, लेकिन सिस में डाइपोल मूवमेंट रिजल्टेंट कुछ बच रहे हैं. दैट इज द रीजन व्हाई दे आर लेस डेंसर देन water, so that even alkenes also float on the water. You can see boiling point, we'll discuss this. Okay, cis, this is cis, net dipole moment is there, whereas trans, net dipole moment is 0. Therefore, so dipole moment of cis is greater than dipole moment of trans. This is very very important. ख्याल में रखो, नोट करके रख दो. So विकास ठीक है. Okay, you are there in the session. I couldn't see you. Okay, कोई problem नहीं. Therefore, A is more polar than B. इसी के कारण boiling point of A is more than B. This is very 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 important. You don't have to worry. Those students who are not able to attend my class, you please attend the recorded session, so that if you have a doubt, in the comment box itself you can write in the recorded session. I personally look into the comments and I write the answers and rewrite the comments. Okay, that's fine. In today's class, my dear students, we discussed about alkene general introduction and the preparation of alkenes. In that, dehydration, dehydrohalogenation, and partial reduction, quinoline, PDBASO4, Lindblad catalyst, and bridge reduction we have seen, and Kolbe electrolysis, and we discussed the physical properties of alkenes. So we had a tremendous class today with a lot of pace. Tomorrow, please make yourself. I am planning to discuss about electrophilic addition reaction with a lot of mechanisms, and get ready with a lot of tips also there. Okay, so please like the sessions and share and subscribe. Okay, be regular in the session. If not able to attend the session, please attend the recorded version also. Thank you very much, dear students. Bye bye, see you.